Space never sleeps. And today, we have one of the most exciting news clusters in weeks. A new interstellar visitor, 3I Atlas, has just revealed fresh details in new NASA imagery. Another comet is breaking apart in front of astronomers' eyes. A red dwarf star has unleashed a blast so powerful it could strip entire planets of their atmospheres. And in the middle of all this chaos, the Milky Way quietly photobombs a comet in one of the most stunning apods of the year. This is your daily dose of space, and today we're exploring everything from the birth of comet fragments, to the death of planetary atmospheres, to the mysteries surrounding our newest interstellar guest. Let's begin. New NASA. Images of 3I Atlas. The new high-resolution images of interstellar comet 3I Atlas mark a turning point in what we thought we knew about this object. Unlike previous frames that showed a faint, distant blur, these new images reveal details of the comet's structure as it passed near Mars, captured by NASA's Mars Reconnaissance Orbiter and confirmed by ground-based observatories. And the surprising part? This comet is unusually clean. No obvious coma, no dramatic tail, no classic cometary glow. Instead, 3I Atlas looks more like a bare interstellar rock coated with volatile dust, similar to Oumuamua, but far more stable. This lack of activity might be telling us something fundamental about its journey. It has probably spent millions of years drifting between the stars, losing nearly all volatile materials along the way. By the time it reached our solar system, only the most stubborn ices remained, not enough for a bright tail. But the real shock comes from its color and reflectivity. The surface appears darker than expected, hinting at radiation damage from cosmic rays. Over interstellar timescales, this bombardment breaks down chemical bonds, turning surfaces into carbon-rich coatings known as tholins, reddish organic compounds common in deep space. If 3I Atlas is coated in these tholins, it could be the oldest natural object we've ever photographed up close. These images also give us the best size estimate so far, between 150 and 300 meters. Not planet killer large, but large enough that if it hit Earth, it would boom. Luckily, it's not coming even remotely close. Still, astronomers are watching closely. Every new frame helps piece together a forensic record of a traveler that has crossed multiple star systems before reaching ours. And we're just getting started. Comet CU 2025 K1 is breaking apart. While 3I Atlas is calm and quiet, another comet named C 2025 K1 Atlas is doing the opposite. It is literally falling apart. New images show multiple fragments separating from the nucleus, a process known as cometary fragmentation, and it usually means one of two things. The comet is structurally weak and can't survive the thermal stress of passing near the sun. The comet got tugged by gravitational forces, especially if it passed close to a planet. In this case, the breakup appears to be caused by thermal cracking. When the sun heats the comet unevenly, one side hot, one side extremely cold, internal pressure builds. Eventually, the surface splits open like a bursting steam pipe. This process reshapes comets and sometimes even creates mini-comets, fragments that drift away on their own trajectories. What's especially interesting is that this fragmentation was predicted. Weeks before the breakup, astronomers noticed sudden fluctuations in brightness, a classic warning sign that internal gas pressure was building. We're now watching a cosmic autopsy in real time. Every fragment tells us something about how comets are built, how they survive, and how they die. This breakup may actually help scientists map the internal structure of the comet, revealing where the densest and weakest regions are located. And in the bigger picture, fragmentation like this might play a role in delivering water and organics to young planets, or, in rare cases, sending dangerous debris toward populated worlds. Luckily, this one poses no threat to Earth, just an incredible show of cosmic physics. A red dwarf star just fired a planet-killing blast. Now we go from broken comets to a violent star. Astronomers recently detected a massive coronal mass ejection from a red dwarf, the kind of star that is extremely common in our galaxy. This flare wasn't just a solar storm, it was a planet killer. Traveling at around 2,400 kilometers per second, this CME could easily strip away the atmosphere of any Earth-like planet orbiting close to that star. This is huge because most potentially habitable exoplanets we've found orbit red dwarfs. These stars are small, long-lived, and make up 75% of all stars in the Milky Way. But they're also extremely active, capable of firing off flares thousands of times stronger than anything the Sun produces. The implications are dramatic. A world might form with oceans, only to lose them in a single stellar event. Life could struggle to develop stable conditions. Even planets in the habitable zone might not actually be habitable at all. But here's the twist. These violent flares might also play a role in sparking chemistry that leads to life by energizing atmospheric molecules. So this massive CME raises a deep question. Are red dwarf systems dead zones, or potential cradles of life shaped by stellar chaos? Today's detection is an important data point and possibly a warning for our search for habitable worlds. APOD shows Comet Lemon and the Milky Way. We end on something calmer and beautiful. The astronomy picture of the day features Comet Lemon, perfectly aligned with the glowing arc of the Milky Way. It's more than a pretty image. It's a lesson in comet physics. The long, straight blue tail is an ion tail, created when solar wind strips electrons from the comet's gas, making charged particles glow. Because the solar wind moves outward from the Sun in a straight line, the ion tail always points away from the Sun, even if the comet is moving sideways. The image is a perfect example of the structure of a comet, how the Sun sculpts comet tails, and how dynamic our solar environment really is. When you look at this picture, you're seeing the interaction between a frozen alien traveler and the invisible forces flowing through our solar system. A snapshot of cosmic cause and effect. Today's space news gave us a full tour of the universe, a new look at an interstellar comet, a comet splitting apart near the Sun, a star unleashing a planet-killing blast, and a calm visual reminder of the beauty drifting above us. If you want more daily updates on space discoveries, mysteries, and new interstellar objects, don't forget to subscribe for your daily dose of space.